Deep in a distant patch of sky, a dark monster is breaking the most sacred law of physics. Astronomers trained their giant mirrors on an empty void, expecting nothing but complete, frozen darkness. Instead, a blinding flash of energy burst out from the edge of the abyss, brighter than billions of stars combined. This light should not exist, yet it is screaming across space toward us right now. If you love exploring the strange secrets of the universe without exaggerated hype, take a quick second to subscribe. Joining this community means you will always be the first to uncover what is truly happening out there in the deep cosmos. Let us step directly into this cosmic mystery together. To understand why this discovery shocked the scientific world, we first have to understand how we look at black holes. For more than a century, astronomers thought about black holes as cosmic one-way streets. Albert Einstein taught us that when a massive dying star collapses under its own weight, gravity becomes unimaginably intense. The gravity pulls inward so hard that space itself bends into a bottomless pit from which nothing can ever return. Around every black hole sits an invisible boundary line known as the event horizon. You can think of the event horizon like the edge of a giant waterfall in space. Once water rushes over the edge of the cliff, it can never flow backward uphill. If anything crosses that line, whether it is a rock, a planet, or even a single beam of light, it gets pulled into the center and vanishes forever. Because light itself cannot escape from inside the boundary, the black hole itself is completely invisible. However, the space just outside this boundary is one of the most violent and energetic places in the entire universe. When a supermassive black hole sits in the middle of a galaxy, its gravity grabs hold of huge clouds of gas and dust. This material does not fall straight down into the pit all at once. Instead, it swirls around the center like water draining down an enormous cosmic sinkhole, forming a giant glowing disk of superheated matter. As this gas swirls closer to the edge, friction and gravity heat it up to tens of millions of degrees. The particles move so fast and rub against each other so violently that they begin to shine with intense brightness. This glowing disk releases giant floods of X-rays, ultraviolet rays, and visible light. When we look up with modern space telescopes, we do not see the black hole itself, but we can easily see this glowing ring of doom matter swirling around the perimeter. Above this swirling disk sits a strange cloud of high-energy particles called the corona. Scientists believe the corona is made of super hot gas charged with magnetic energy hovering right above the central whirlpool. When lower energy light from the spinning disk passes through this corona, the particles kick the light up to extreme energy levels. For decades, every computer model and theoretical equation told researchers exactly how this light engine should behave under normal conditions. The mathematical rules governing this system seemed solid, predictable, and fully settled. Scientists knew that the brightness of a black hole system could rise and fall slowly as it swallowed new gas over thousands of years. They believed that sudden violent changes in light were physically impossible because the sheer scale of the gas disk is millions of miles across. It takes time for changes to ripple through such a massive structure, meaning the light should remain relatively steady over human lifetimes. Then, an automated sky survey picked up an event that shattered every single one of those predictions. In early 2018, an automated network of telescopes called the All-Sky Automated Survey for Supernovae, or ASSN, scanned a galaxy named 1ES 1927 plus 6654. This galaxy sits roughly 275 million light-years away from Earth in the northern constellation of Draco. At its heart lies a supermassive black hole containing the mass of several million suns. Under normal circumstances, this distant black hole was quiet and minding its own business. But suddenly, the automated survey detected a sudden flash of optical light coming straight from the galaxy's center. Over the course of just a few months, the center of this galaxy grew 40 times brighter than it had ever been before. Astronomers around the world received the alert and quickly aimed the most powerful observatories on Earth and in space directly at the target. What they witnessed over the following year completely baffled the global scientific community. A team of researchers led by astrophysicist Aaron Kara used NASA's NICER telescope, an instrument mounted on the International Space Station, to track the X-rays. They also used the Swift X-ray telescope in the European Space Agency's XMM Newton Observatory to monitor the event around the clock. Everyone expected the black hole to simply swallow a snack and slowly return to its standard glowing state. Instead of staying bright, something completely unnatural and unexpected took place. The high-energy X-ray light from the corona did not just flicker or dim slightly. Over the course of barely 40 days, the X-ray emissions dropped by a factor of 10,000 until they completely vanished. The corona, a massive cloud of energetic particles that had been shining for millions of years, suddenly ceased to exist. Imagine looking up at a lighthouse on a rocky coast and watching its bright, rotating beam turn off in the blink of an eye. In space terms, a 40-day collapse for a structure spanning millions of miles is faster than an instant. Scientists had never seen a black hole corona completely shut down in real time. It was as if someone had reached into the heart of the galaxy and pulled the power cord out of the wall. For months, the black hole sat in complete X-ray darkness, baffling the researchers who monitored its signal every single day. The standard textbook said that a magnetic corona could not simply evaporate without leaving behind clear physical clues. The equation suggested that the energy required to destroy such a massive magnetic field would blow the entire galaxy apart. Yet there it was, sitting totally dark in the high energy spectrum, defying every known law of astrophysics. Then came the moment that made the researchers question everything they knew about gravity and magnetic fields. About 100 days after going completely dark, the X-ray light suddenly flickered back to life. It did not return slowly or gently over centuries like the models predicted. The light roared back with incredible fury, becoming hundreds of times brighter than it was before the shutdown, blazing with an intensity that completely broke the standard radiation scale. Have you ever seen something happen that completely went against what everyone told you was possible? Drop a comment below with your thoughts on whether you think our current physics laws are missing a huge piece of the puzzle, and be sure to hit that like button to help spread real science to more curious minds. Scientists originally thought these magnetic structures were permanent features that could only change across deep geological time. They believed that once a black hole established a stable accretion disk and a corona, that structure would remain intact for eons. The physical size of the system is so massive that altering its magnetic field was thought to require the collision of entire star clusters. Seeing it vanish in 40 days and rebuild itself in 3 months was like watching an entire mountain range crumble into dust and rebuild itself by lunchtime. The researchers developed a working theory to explain what might have triggered this impossible light show. They suggested that a rogue star wandered slightly too close to the black hole's gravitational grip. When a star gets trapped by a supermassive black hole, the tidal forces pull harder on the front of the star than on the back. This extreme gravitational difference stretches the star out into a long, thin stream of hot gas, an event astrophysicists call spaghettification. Under this theory, the shredded remnants of the star did not fall neatly into the existing swirling disk. Instead, this runaway stream of stellar debris slammed violently into the inner edge of the gas disk. The collision created massive turbulence, smashing the delicate magnetic cage that held the corona in place. With its magnetic skeleton completely destroyed, the corona collapsed inward and plunged straight through the event horizon into the darkness. Once the star's material finished falling into the void, the remaining gas disk began to settle down again. As the gas continued to swirl and rub together, new magnetic fields began to generate from scratch through a natural dynamo process. These fresh magnetic lines twisted around each other, snapped, and released a violent wave of trapped energy. This sudden magnetic reconnection kicked the new corona into overdrive, creating the blinding flash of light that lit up telescopes across Earth. While this star collision theory provides a plausible timeline, it still leaves a huge number of troubling questions unanswered. The amount of energy released during the rebirth of the corona was far greater than what a single shredded star could provide. The light also contained strange frequencies and polarization patterns that should not have been able to escape the intense gravity near the horizon. Something else was happening right at the edge of the void, something that pushed our understanding of light to its absolute limit. This brings us to a second, even stranger discovery made by a different team of astronomers looking at another supermassive black hole. Deep inside the galaxy I Zwicky 1, located 800 million light-years away, astrophysicist Dan Wilkins from Stanford University was studying the swirling corona using the XMM Newton and NuSTAR space telescopes. He was tracking how X-ray flares bounce off the gas disk to map the geometry of the extreme environment. What he saw was a series of bright, powerful X-ray flares erupting from the front of the corona, which was completely expected. When a corona flares up, the light travels out in all directions, illuminating the gas disk just like a flashlight beam reflecting off a shiny tabletop. Telescopes on Earth easily pick up these direct flashes and their immediate reflections bouncing off the nearest gas clouds. Then just milliseconds after the main flares, the telescopes picked up something that made the entire research team freeze. A series of secondary flashes appeared in the data, glowing with distinctly different colors and shifted wavelengths. These secondary flashes were smaller and slightly delayed, acting like echoes of the primary explosion. But when the team analyzed the direction of these echoes, they realized something that sounded completely impossible. The light echoes were not coming from the front of the gas disk or from the sides. The data proved without a doubt that these flashes of light were originating from directly behind the black hole. Think about what that actually means for a moment. A black hole is a completely solid sphere of dark space that blocks all light and absorbs everything that hits it. Seeing light from behind a black hole should be as impossible as seeing the back of your own head in an ordinary flat mirror. For decades, basic common sense told people that if an object sits directly behind a solid sphere, that object is hidden from view. If you stand behind a giant brick wall, someone on the other side cannot see the flashlight you are holding. A black hole is the ultimate brick wall, absorbing every stray particle and bending space into a dark barrier. Nothing should ever be visible if it happens on the far side of the event horizon, yet the telescopes were clearly catching light that started behind the monster and traveled straight to our sensors. The explanation for this impossible optical trick lies in one of the wildest predictions of general relativity, an effect known as gravitational lensing. The gravity around this supermassive black hole is so monstrous that it does not just pull on physical objects. It literally bends and warps the fabric of space itself. When the flare erupted behind the black hole, the light did not travel in a simple straight line. As the light beams tried to shoot past the event horizon, the extreme gravity bent the empty space around the perimeter into a tight curve. The light was forced to follow this curved path, wrapping completely around the edge of the dark sphere like water curving around a smooth stone. The gravity acted as a massive curved mirror, bending the light around the corner and firing it directly toward our telescopes on Earth. Albert Einstein predicted over a century ago that intense gravity could bend light around massive objects like stars and galaxies. However, he never imagined that we would one day have instruments sensitive enough to watch light curve around the backside of an active black hole in real time. This was the very first time human beings directly observed light originating from the dark, hidden side of a cosmic abyss. Does the idea of gravity bending empty space so hard that you can see behind an invisible object blow your mind? Take a moment to subscribe if you want more mind-bending space discoveries delivered straight to your feed, and tell me in the comments if you ever learned about gravitational lensing in school. The discoveries did not stop with bent light and vanishing coronas. In recent years, astronomers using the most sensitive X-ray observatories have detected another type of light that breaks standard models, ultra-fast outflows glowing with impossible energy. In several active galaxies across the universe, supermassive black holes are blasting out giant winds of gas moving at nearly one-third the speed of light, which is roughly 200 million miles per hour. As these ultra-fast winds slam into the surrounding galaxy, they produce high-energy gamma rays and extreme ultraviolet radiation. The strange part is where these winds originate. According to classical physics, the intense gravitational pull near the event horizon should pull everything downward into the pit. For material to escape at such ridiculous speeds, an outward force must exist that completely overpowers the strongest gravity in the universe. Scientists discovered that the light itself is providing the muscle for this cosmic cannon. When the accretion disk gets packed with too much matter, the radiation pressure becomes so intense that photons literally push against the falling gas particles. The light acts like a powerful physical piston, shoving enormous clouds of gas backward into deep space before they can cross the point of no return. This creates an extreme tug of war where light and gravity battle for dominance right on the razor edge of the horizon. This constant battle produces strange, pulsating rhythms of light that scientists refer to as quasi-periodic oscillations. These are regular, repeating flashes of X-ray light that tick like an ultra-fast cosmic clock, flashing several times every second. For years, theorists believed these ticks were caused by the inner edge of the gas disk wobbling like a spinning top as it gets dragged by the spinning black hole, an effect known as frame dragging. However, recent high-precision measurements from the NICER observatory have revealed that some of these light pulses are moving far faster than the speed of the disk itself. In some extreme systems, the light pulses flash at frequencies that would require the gas to travel faster than the speed of light, which violates the fundamental speed limit of the universe. This means our standard picture of how matter behaves in extreme gravity is still missing a crucial ingredient. To find answers, scientists turned their attention to an even more extreme class of objects known as ultra-luminous X-ray sources, or ULXs. For decades, researchers believed these blinding beacons of light were medium-sized black holes, weighing hundreds of times more than our sun. They assumed that only a large black hole possessed enough gravitational power to hold onto a disk bright enough to generate such intense radiation without blowing itself apart. Every object in the universe has a natural speed limit for how much light it can produce, known as the Eddington limit. If an object shines brighter than this limit, the outward push of its own light will blow away all its fuel, cutting off the power source and causing the object to dim. For a long time, the Eddington limit was treated as an unbreakable ceiling in astrophysics. Then, astronomers using NASA's New Star Space Telescope looked closely at several ultra-luminous sources and discovered something that shocked everyone. Many of these impossible light generators were not giant black holes at all. Some were tiny, dense neutron stars that were somehow shining hundreds of times brighter than their theoretical Eddington limit should allow. They were producing light that defied every standard equation of stellar physics. Scientists realized that ultra-strong magnetic fields could warp the way light interacts with matter. If a magnetic field is trillions of times stronger than Earth's magnetic field, it can compress atoms into thin, needle-like shapes. This allows radiation to slip past the matter without pushing it away, letting the object swallow gas and shine with impossible brightness without destroying its own fuel supply. This discovery opened up an entirely new way of thinking about black holes and their strange light emissions. If extreme magnetic fields can alter the basic interactions between light and matter, the region surrounding a black hole is not just a simple gravitational sinkhole. It is a complex, churning magnetic laboratory where the standard rules of physics are twisted into shapes we are only beginning to comprehend. Every time our telescopes peer deeper into these extreme environments, they reveal that the universe is far stranger than our neat mathematical models suggest. What once seemed like settled science is being rewritten with every new observation, showing that nature always finds ways to bypass what we thought were absolute limits. If you're enjoying this deep dive into the unexplained mechanics of our universe, share this with a friend who loves deep space mysteries. Drop a quick comment letting me know which cosmic phenomenon confuses you the most, and do not forget to hit that subscribe button to stay updated with every new breakthrough. This brings us to one of the most exciting and ongoing puzzles in modern astronomy: the mysterious flares coming from the center of our very own Milky Way galaxy. At the heart of our home galaxy sits Sagittarius A, a supermassive black hole with the mass of 4 million suns. For most of human history, Sagittarius A has been a remarkably quiet neighbor, snacking on small wisps of gas and glowing with very dim light. Because it is relatively quiet, astronomers consider Sagittarius A the perfect baseline for studying a calm, mature black hole system. Instruments like the Chandra X-ray Observatory, the Very Large Telescope in Chile, and the Keck Observatory in Hawaii have kept a watchful eye on our galactic center for over 2 decades. They mapped the precise orbits of nearby stars and established a predictable pattern for the black hole's daily energy output. Then, in May of 2019, astronomers watching Sagittarius A through the Keck telescope saw something that had never been recorded before. In a matter of just 2 hours, the infrared light coming from the edge of the black hole surged to more than twice the brightness of any previous observation. The point of light flared up violently, glowing 75 times brighter than its normal baseline before slowly fading back into the darkness. Astrophysicist Tuan Do from the University of California, Los Angeles, was analyzing the data in real time and initially thought he was looking at a bright nearby star. When his team checked the exact coordinates, they realized the blinding light was coming straight from the event horizon itself. The black hole had suddenly become hungrier and more active than at any point since modern observations began. Astronomers initially thought this unprecedented flare was a one-time fluke, perhaps caused by a small asteroid or a dense gas cloud falling into the trap. But over the following months, Sagittarius A also produced several more high-energy flares, shining brightly in both infrared and X-ray wavelengths. The quiet monster at the center of our galaxy was waking up, and nobody could agree on why. One leading idea is that a mysterious object known as G2, which passed close to Sagittarius A in 2014, had finally delivered its payload. Scientists originally thought G2 was a simple cloud of gas that would get ripped apart immediately upon approach. Instead, G2 survived its close encounter, leading researchers to believe it might be a pair of binary stars that merged into a single star wrapped in a thick dust envelope. As this strange hybrid object swung past the black hole, the intense gravity may have stripped away its outer layers of gas. That stripped gas took several years to slowly spiral down the cosmic drain, finally hitting the inner accretion zone in 2019 and triggering the massive flare-up. If this idea is correct, we are watching the delayed digestion of a stellar collision that happened millions of miles away from the horizon. Another theory points to a sudden shift in the black hole's magnetic field lines, similar to the solar flares produced by our own sun. When magnetic lines twist around each other in the swirling gas disk, they can snap and reconnect in a fraction of a second. This reconnection releases enormous bursts of trapped kinetic energy, accelerating electrons to nearly the speed of light and creating sudden, blinding flashes of synchrotron radiation. The mystery of Sagittarius A is happening right now in our own cosmic backyard, showing that even quiescent black holes can suddenly change their behavior without warning. The Event Horizon Telescope, a global network of radio dishes working together as an Earth-sized telescope, is constantly gathering new data to capture real-time movies of these dynamic flares. We are on the verge of watching the edge of an abyss change its shape and brightness right before our eyes. What do you think is causing the monster at the center of our galaxy to suddenly wake up and flare so brightly? Drop your best theory in the comments section below, and take a quick moment to like the video if you find these real-time cosmic events as thrilling as I do. To truly appreciate why this impossible light matters so much, we have to look at what it tells us about the ultimate fate of space, time, and gravity. For almost a century, theoretical physicists have faced a massive wall known as the information paradox. Albert Einstein's theory of general relativity describes gravity as smooth, continuous curves in the fabric of space-time, working perfectly on massive scales like stars and galaxies. On the other side of physics sits quantum mechanics, the set of rules that governs the tiny world of atoms, electrons, and subatomic particles. Quantum mechanics states that information about physical particles can never be truly destroyed. Every interaction must leave a trace that can theoretically be traced backward in time. But when an object falls into a black hole, general relativity says that all its physical properties are erased forever, leaving behind only mass, spin, and electrical charge. This direct clash between the two greatest theories in science is one of the deepest unresolved problems in all of human knowledge. The famous physicist Stephen Hawking made the problem even more dramatic in the 1970s when he discovered that black holes are not completely black. Using quantum mechanics, Hawking showed that pairs of virtual particles are constantly popping into existence near the edge of the event horizon. Normally, these particle pairs appear, collide with each other, and instantly vanish back into empty space. But right at the event horizon, one particle can fall into the void before the collision, leaving the other particle stranded outside in the real universe. The surviving particle flies away into deep space as a tiny wisp of radiation, now known as Hawking radiation. Because this escaping particle takes away a tiny fraction of the black hole's mass, the black hole will very slowly shrink and eventually evaporate into nothing. This creates a terrifying theoretical crisis. If a black hole eventually evaporates completely away through Hawking radiation, where did all the information go that fell inside over billions of years? If an entire encyclopedia or a massive star falls into the dark and the black hole eventually disappears, is that history permanently wiped from the universe? If information can truly be destroyed, the fundamental equations of quantum physics fall apart completely. This is precisely why every strange beam of light escaping from the vicinity of a black hole is so critically important to science. When we observe light echoes curving around the back of the horizon or watch coronas rebuild themselves from magnetic chaos, we are looking at the boundary where general relativity and quantum physics are forced to touch. The light we are detecting carries physical fingerprints of extreme space-time that cannot be recreated in any laboratory on Earth. Some theoretical physicists believe that the light escaping from these extreme environments might carry subtle encodings, tiny quantum signatures, that reveal how gravity behaves at the smallest possible scales. By measuring the exact polarization, energy levels, and timing of these unexpected flares, researchers are searching for clues to a unified theory of quantum gravity, the holy grail of modern physics that could explain how the entire cosmos works. Every impossible light flash we record is like a message sent from the edge of reality, giving us a rare glimpse into the true machinery of the universe. We are no longer limited to dry chalkboard equations and abstract thought experiments. We are using real telescopes to watch real matter interact with the most extreme forces in existence, testing the boundaries of human knowledge in real time. When you look up at the night sky, it is easy to view space as a cold, static, and unchanging backdrop of distant, glowing dots. But discoveries like these remind us that we live in a dynamic, active, and endlessly surprising universe that refuses to follow our neat human assumptions. The laws of nature are far richer and more flexible than our textbooks ever imagined, waiting for us to ask the right questions and build better tools to see what is really out there. Understanding these distant cosmic giants also helps us understand our own place in the vast timeline of the cosmos. The supermassive black holes sitting in the centers of distant galaxies are not just destructive monsters that swallow light. They are the cosmic engines that shape entire galaxies, driving powerful winds that trigger the birth of new stars and regulate the growth of planetary systems like our own. Without the violent energy released by these central engines billions of years ago, the gas in early galaxies might have collapsed too quickly, preventing stable solar systems from ever forming. The carbon, oxygen, and iron flowing through your blood and making up the world around you were forged inside ancient stars and scattered across space by these very same galactic processes. In a very real and literal sense, we are the direct products of this wild, energetic, cosmic history. We are living in an extraordinary golden age of astronomy, where new observatories like the James Webb Space Telescope and next-generation X-ray missions are peering deeper into the void than ever before. Every single week, new data arrives that challenges what we thought was possible, proving that the universe is still full of wonders waiting to be uncovered by curious minds. If you made it this far, thank you so much for joining me on this incredible journey to the edge of space and time. Please take a moment to subscribe, turn on notifications so you never miss a new discovery, drop a comment answering what you think is the biggest unsolved mystery in space, and share this video with someone who loves exploring the secrets of our universe.